In this case, we are interested in the calculation of current in 2 ohm resistance. This 2 ohm, RL is mentioned here, which is 2 ohm. Apply the steps and find out its current in 2 ohm resistance. Now, it is not a complicated problem. This is simple. Just apply the steps fastly, because in this lecture, I want to cover at least 5-6 problems. Because you have to solve this problem within 5 minutes. Is it right? Apply the step number 1. And you have to give me the answers for your calculations. Removing the load resistance and shorting the output terminals, we get. Removing RL and shorting output terminals, we get. Is it right? Draw its figure and do the calculations. If we are removing the load resistance, then figure will be something like this. I will give some names to these terminals, maybe A and B. Here is the load resistance. This will be the voltage source. And here, this is the another resistance, and we are shorting these terminals. And we are interested in this current, which is the Norton's current. That is current in the short circuit, which is the Norton's current for this case. Oh, sir. So here in this case, we are removing the load resistance and we are redrawing the same circuit, and we are interested in the calculation of the current in the short circuit. This is 6 ohm, this is 5 ohm, this is 8 ohm, and this value is the 4 ohm, and this voltage is the 12 volt. Again, whenever we have this complete path is the short circuit, never use the nodal analysis method. In this case, we can use the direct inspection method. This is 1 loop, 2nd loop, 3rd loop, because we have only the independent sources and voltage sources. सिर्फ voltage sources है तो हम use कर सकते हैं direct inspection method. Otherwise, I will recommend to use the mesh analysis. This is loop 1, its current is I1. This is loop 2, its current is I2, and this is loop 3, its current I will name it as IN. That is the Norton's current. Use the mesh analysis or use the direct inspection method. Choice is yours. Here in this case, just last problem I have solved by using the mesh analysis. You are aware of the mesh analysis. That's why I will prefer to use the direct inspection method here. I will use the direct inspection method. How is the direct inspection method? This is the impedance matrix into this current matrix is equal to the constant matrix. It will be the general format for this matrix. And how is our impedance matrix? I will draw here. This is R11, this is R12, this is R13, this is R21, this is R22, this is R23, this is R31, this is R32, and finally it is R33. These are the elements of the matrix. First I will find out R11, that is resistance of this first loop. How much is the resistance of the first loop? I guess 14. Then how much is the R22, resistance of the second loop? The resistance of the second loop is 8 plus 5, 13 plus this 4, 17 I guess. This is 17. If I'm doing the wrong calculation, please remind me. And finally, we are finding the this R33, resistance of the third loop, which is 6 plus 5, which is nothing but the 11. Only the diagonal elements are positive in this method, remaining all elements are negative. Then we will find out these two elements, R12 and R21 resistance, which is common for the first and second loop. This is first loop, this is second loop. Its resistance common is 8, means it is minus 8 is here. This is minus 8. Then we will find out R31 or R13. R31 and 13. This is first loop, this is third loop. The common element is the 6, means its value is minus 6 is here, here is minus 6. Then finally we will find out this value R23 or R32. R23, 2 and third, this is the resistance which is common is minus 5, here is minus 5. The currents are I1, I2 and I3. And constants are, for first loop, if we are traveling with the direction of the current, we are traveling from negative to positive, plus 12 is the constant. For second loop, constant is 0. For third loop, the constant is 0. Is it right? This is the direct inspection method. Here, by inspection method, we will get this matrix. We'll get this matrix, and from this matrix calculate its I3. It is not I3, it is actually IN. Calculate I1, calculate I2 and calculate IN. But here we are interested in IN only. We are interested in IN only, and that is nothing but the Norton's equivalent current. Calculate its value and tell me the answers. I'm waiting for answers from your side. Just use your calculator. Shift the calculator in the equation mode and enter the values and get the answers. Yes, anyone? Yes. Saurabh.
I1 is equal to 4.11.
4.11 amperes.
I2 is equal to
3 amperes.
I3 is equal to 3.61 amperes.
3.61 amperes. Is here. In this case, the Norton's current as per this particular method is this. Be careful, all of you. Whenever there is a short circuit, whenever this complete branch has zero resistance, don't use the nodal analysis method. Don't use the nodal analysis method, because in case of the Thevenin's theorem, majority time I have preferred the Norton's nodal analysis method, because in that case the chances of becoming that resistance is zero is negligible. But here in this case, in case of the Norton theorem, every time that branch may get the zero resistance. That's why generally in case of the nodal analysis method, try to use the mesh analysis or direct inspection method while calculating the current. Otherwise, use any method, but check it out first whether that method will not lead to the wrong calculations. That care you have to take on. Now, for the calculation of Rn, we are removing load and shorting output, removing the load resistance, and all sources are replaced by respective internal resistances. Draw its figure. How is the figure? I will show. This is one point A, this is one resistance, this is the second resistance, this is the B point, this is B point, this is A point. Here is one resistance. Here is another resistance which is of the 4, and this path is voltage source, and that voltage source should be replaced by zero resistance, that is short circuit. This is 4 ohm, this is 5 ohm, and this is the 6 ohm, and here it is the 8 ohm. Use the series and parallel combinations and find out its resistance between the terminals A and B. How will be its next figure? I will draw here. Now, use the series and parallel combination. What I will do, I will shift this point here. I will shift this point here, because this has a wire. The wire may be longer one or maybe shorter one. Directly, I will put this point here. In that case, our figure will be something like this. This resistance as it is, this 5 ohm as it is. This point is the B point. If I am shifting this point directly here, how is the case? In that case, it will become something like this. This is 8 ohm. Is it right? At the same time, this point will be here. This figure will be something like this. Here it is 4 ohm, this is 8 ohm, this is 6 ohm, and this will be the 5 ohm. If anyone has any doubt regarding these modifications of the figure, you can raise your hand. I will clarify your doubts. Is it right? Now these two resistances are parallel combination is series, and then finally parallel. This how will be its next figure? This next figure will be something like this. I will draw here. Its next figure. These are the two parallel. This is the A point. Here is the parallel combination. This is 5 ohm. This point is the B point. There is the A point. And this resistance is as it is. This 4 ohm. This is 5 ohm. And how much is the parallel combination? Anyone?
3.4.
3.4 is that parallel combination. 3.4 ohm is the parallel combination. Then draw its next figure. This next figure will be something like this. Here is A point, this is B, and it will be something like this. This is 4 ohm, and its series combination will be 5 plus 3. 8.4. This is 8.4 ohm is this parallel combination. And finally, find out its resistance, which is the Norton's resistance, that is Rn, which is equal to 8.4 into 4 divided by 8.4 plus 4. Work out this calculation and find out its value. Anyone? Shivani? Yes.
2.7.
2.7 ohm is the parallel combination. All of you need to be improving the calculations because many of the students are there. I have not seen them single time giving the answers. You need to be interactive. Rishikesh, Rohan, then Shailesh, Shivani. All of you, you need to be interactive. Is it right? Now here we know the IN and we know the RN. Then we will draw its equivalent network. Is it right? If we know IN and RN, complicated network, is replaced by Norton's equivalent network. Is it right? Norton's equivalent network. How will be the Norton's equivalent network here? It will be something like this. Here is the resistance and connect the load resistance which is removed in the first step. How much is the load resistance if we are looking at this? If we are coming to this problem, load resistance is 2 ohm. And how much is the IN? 3.61. This is 2 ohm and this current is 3.61 amperes. Now, how much is the load resistance which we have calculated? Norton's equivalent resistance which we have calculated. The Norton's resistance is the 2.7 ohms. Here in this case we know the Norton's equivalent resistance and everything. This will be the 2.7 ohm. Now we can find out its load current which is equal to IN into RN divided by RN plus RL. IN is 3.61 into RN which is 2.7 divided by RN plus RL 2.7 plus 2 and find out its load current.
2.07.
2.07. 07 amperes is the current flowing through this particular circuit current flowing through the load resistance, which is of the 2 ohm, using the Norton's theorem.